Unit 4 Review, Problem 1. The investment firm Brown & Johnson reported that 52.7% of 300 randomly selected American households owned stocks. Does this result provide sufficient sample evidence to indicate that a majority of households in America own stocks? Use alpha equals 0.05. So here the question is asking, does this result provide sufficient sample evidence? The answer is either going to be yes, it does provide sufficient sample evidence, or no, it does not. This type of inferential statistics problem is best answered by using a hypothesis testing procedure. Because the hypotheses, the null H0 and the alternative H1, will represent one of these answers. One of these will answer yes, this does provide sufficient sample evidence, and the other one will give the opposite answer. No, this result does not provide sufficient sample evidence. So conducting a hypothesis test procedure is one of the best ways to answer this type of question. Now, the question, does this result provide sufficient sample evidence to indicate that a majority of households in America own stocks, is basically referring to one single population, households in America. So this will be a hypothesis test procedure conducted on just one population, households in America. And whether this test involves a mean or proportion, we need to look at the data. In this case, 52.7% of 300 randomly selected American households. The sample result of 52.7% is a percentage or proportion. So this problem is best answered by using a hypothesis test procedure on one population proportion. So here we'll look at these steps to take us through all the steps of conducting this hypothesis test procedure. The first step in any hypothesis test procedure is to state the hypotheses. Symbolically, we express the hypotheses as the H0 to represent the null and H1 to represent the alternative. Now, this is a test for one population proportion. Symbolically, we use the symbol P to represent the one population proportion. Next, we have to determine whether this test involves an equal versus not equal case, or is it a greater than equal versus less than test? Or does it involve a less than or equal versus a greater than test? To decide which one of these three pairs of comparisons we're using, we need to look at the question being asked. And the question is, does this result provide sufficient sample evidence to indicate that a majority of households in America own stocks? Here the key is that a majority of households. And as far as a proportion goes, in order for it to fall in the majority, that means the proportion must be over 50% or more than half, because the majority is anything over that 50%. Over is a greater than. Greater than always shows up in the alternative, H1. And more than half can be represented as the fraction, 1/2, or more than 50% can be represented as the percentage or as the decimal, 0.50. In this case, I use the H1 to be P greater than 50%. And if it truly is that the population proportion P is greater than 50% or more than half, then we can conclude that yes, indeed, a majority of households in America own stocks. Now, whenever the alternative H1 involves the greater than, the null hypothesis always involves the opposite and equal to. So HO, the null hypothesis, is represented as P less than or equal to the 50%. Now we've completed the first step, stating the hypotheses. Now we get to move to the second step. Identify alpha, the level of significance. It's customary in every hypothesis test procedure to use alpha equals 0.05 or 5%, unless stated otherwise. This problem does state to use alpha equals 0.05, so we'll be using the alpha equals 0.05 as stated. But even if this problem didn't mention or ask us to use a level of significance alpha 0.05, That's the same level we would have used anyways, because it's the customary standard used in any hypothesis test. Now with the second step completed, we go to the third step, which is where we use the sample data to calculate the p-value that we're going to use to make our decision. In a hypothesis test procedure for one population proportion, the one prop z-test command on the TI-83 or TI-84 calculator will help us calculate the p-value. To get to this command, we press Stat, arrow over to the test menu, and then arrow down to find one prop z-test. And we press Enter to select. On the one prop z-test screen, we have to enter in the specific values the calculator needs to help us calculate the p-value. The first item the calculator is prompting us for is labeled as PO, which is basically the calculator's notation for asking what does the actual population proportion P equal in HO, the null hypothesis. In this case, we see in HO, P could equal the 50%. So with the cursor blinking next to PO on the calculator, we type in the 50%. But since the calculator is a decimal machine, we enter 50% in the decimal form as 0.50. After we've entered in the 0.50 for PO, the calculator then is prompting us for the X, which is the data value for what this problem was about, and N, the total sample size that was used in this problem. So here we look back to the sample data. Here we're given that 52.7% of 300 randomly selected American households own stock. The 52.7% is the sample proportion, P hat. And the 300 randomly selected households is in the total sample size. So we would have to enter in the N equals 300 into the calculator, so that the calculator knows the total sample size is 300. And then as far as entering the value for X, in this problem, X, the data value, is not given. But we know that when the proportion P hat is known and the total sample size N is known, we can calculate for ourselves the X data value by multiplying N, the total sample size, times P hat, the population proportion. So X, the data value in question, in this case, the number of the actual American households in this sample that own stocks, is calculated by taking N, the total sample size, which was given, 300, and multiplying it by P hat, the sample proportion, which was given in the problem as 52.7%. But when we enter the 52.7% in our decimal calculator, we convert this number to the decimal, 0.527. So to calculate X, we would take the number 300 times 0.527, enter, gives us the value of 158.1. But if you were to enter 158.1 in this command for X and go down to calculate, the calculator would give you an error. That's because in proportion problems, X, the how many, and N, the total sample size, are discrete, that is, whole numbers only. So the 158.1 is impossible. You can't have 158.1 American households in the sample own stocks, because the American household either owns stocks or it doesn't. There's no in between. So we need to round off our answer here to the nearest whole number. 158.1 is closer to 158 than it is to 159. So we enter in the calculator for X, 158. So with 158 entered in for X and 300 entered in for N, we then move the blinking cursor to the next line where we have to tell the calculator what comparison do we have in our alternative or H1 hypothesis. There's only three choices. H1, the alternative, either includes a not equal to, or a less than, or a greater than comparison. looking at the H1 alternative in our problem here, we see that P is greater than 50%. So we need to arrow the cursor over so that it's blinking on the greater than and press enter to select. Now the calculator is matched up with the hypothesis that we're testing in this problem. Now that we have all the information inputted, we can arrow down so that the blinking cursor is on calculate and press enter. The calculator will then take all this information and calculate the p-value we need to go to our next step. That is, reach the decision and then state the conclusion. All hypothesis tests have the same decision rule. You either reject HO, the null hypothesis, whenever the p-value that is calculated is less than or equal to alpha, the level of significance. Otherwise, if the p-value is bigger or greater than alpha, we do not reject HO. So once we have the p-value, we can then reach our conclusion to either reject or not reject, based on whether this p-value is less than or greater than the alpha. And once we made that decision, we then do the final step of the hypothesis test procedure, which is state the conclusion. Stating the conclusion is just interpreting in context, that is, in words of the problem, what the reject HO or the not reject HO decision means. So in this example, when we press enter with the cursor blinking on calculate, we get the screen displaying all kinds of calculated numbers. But the one number we're interested in is the p-value, the one that says p equals 0.1778. Now, p-values are probabilities, so we can round our probabilities to 3 places after the decimal. So that means we look at the 4th place, in this case an 8. Anytime that decimal is 5 or higher, we round the next number up. So in this case, the 8 rounds the 7 up to an 8, and we write that the p-value is approximately 0.178. Now that we have our p-value, we can make our decision by comparing it to alpha, the level of significance. The p-value of 0.178 is not less than or equal to 0.05. And when the p-value is not 0.05 or less, the decision is to not reject HO. And when we do not reject HO, it implies that you cannot conclude H1. So the idea represented in the alternative H1, where P is greater than 50%, is not supported by the data. So we cannot conclude that the actual population proportion P is greater than 50%, which in this case means we cannot conclude that it's a majority of households. So now we have enough information to reach our conclusion. Therefore, this result does not provide sufficient sample evidence to indicate that a majority of households in America own stocks. So be sure when you are writing your solutions to show all of your work, to show your reasoning and method of solving the problem. In a hypothesis test, that includes writing the null, HO, and alternative H1 hypotheses out clearly. Also, identifying alpha, the level of significance being used. You also have to show all your work and calculations that are done to calculate the p-value. This includes communicating what command on the TI-83 or 84 calculator that was used. And then you need to show what the p-value is and also show the reasoning for why we made the decision. In this case, the decision was to not reject HO. You need to clearly show that the reason was because the 0.178 or 17.8% was greater than the 0.05 or 5%. And then based on that decision, in this case to not reject, you then have to answer the original question in words of the problem, interpreting what that decision means. In this case, not rejecting HO means we do not have sufficient sample evidence to support H1. So that's why we answer this question as no. Therefore, this result does not provide sufficient sample evidence to indicate that a majority of households in America own stocks.